Today we're going to talk about exposure and how light and exposure work together in a video camera. At Vario, we manufacture the HD18, which is probably the best camera in its class manufactured in the United States. It's a high-definition camera. It has a CCD sensor. It provides auto and manual iris. It provides you with adjustable gamma. It has an excellent dynamic range and very, very low flare on the lens. So lens aperture is the amount of light you allow to go through your lens into the imager. And as such, it impacts the depth of field, which is what is in focus and what is not. On the left side, you can see at a larger aperture, like an f2.8, the object in front is very well in focus and the background is blurred. This is very nice when you're shooting a movie or something that has to be in that condition, like two people talking, having an argument, and whatever happens in the background is irrelevant. So you want the foreground to be clearly in focus and the background to be blurred. On the other hand, if you want everything to be in focus, like you're shooting a manufacturing facility, a car manufacturing facility, or a church, you want everything to be in focus, then you will use a lower iris setting or a higher f-stop, like an f16. Then it will allow you a much greater depth of field, but it will require more light. So here's a chart that explains the exposure. There are two ways in which you can achieve a higher exposure. One is opening up the iris, or to expose the semiconductor or the CCD or CMOS to a longer exposure time. So here we see when we play with that, which is the shutter setting, the amount of light that goes through at 1/2000th of a second as compared to 1/15th of a second. So if you're running into a situation where you don't have enough light, you could extend the exposure. But the consequences of that are also important to consider. If the shutter is high, which means that the exposure time is low, therefore it compensates for excessive light. If you do that, you can keep your depth of field by opening up the iris. However, if your light is a gas discharge light, you will face a situation where your white balance will change constantly. In order to understand this, let's talk about the image sensor. In this case, we'll talk about the CCD. So the photoelectric effect, what it does, the photons reach the semiconductor and electrons are moved out of that semiconductor when the light hits that device. So what you can see here is the light comes down into the photosensor and then it will cause the electrons to move out and create a current. In the CCD operations, the charges are captured as a whole, one full frame, and moved into the vertical register. Once it's in the vertical register, it's covered and it stays as information, and it's then clocked out in a serial form. The CCD has its advantages and disadvantages. On the advantages, it has a mature technology. Its surface is clear of any auxiliary circuits, which means there are no circuits causing the pixel to be smaller. It has a very large photosensor. CCDs have usually very high sensitivity, have very good signal-to-noise ratio, and very good dynamic range. On the other hand, it requires a dual voltage power supply. It has high power consumption, therefore it gets very hot. It needs a heat dissipation device, like a heat sink or a fan. You cannot change the spatial resolution. The pixels you have are the pixels you have. You cannot choose smaller amount of pixels like you can do on a CMOS. And of course, it is a more complex driver circuit. It needs several different clocks to move the charges out of the vertical register into the horizontal register and so on. And what's typical on the CCD is that it has, when it aims into a very bright light, you will get what's called vertical smear, or this very vertical bright light. In the global shutter, which is typical of a CCD, when you use the shutter, you capture one complete image. not portions of it or lines. It's one still frame. Now the exposure of that frame can be timed either to 1/60th or lower or longer if it's a longer integration. If it's lower in time or longer in time, you will understand now what it causes. In this chart, the gas discharge, when you're using it in fluorescent light, the fluorescent light starts from a very bluish light, goes into red, and then it turns off, and it goes into blue again, and then it turns off. We don't see that, but the camera does. If the shutter is on, which means the exposure is less than a 60th of a second, you will see the hue of your camera change. So we'll go from a very reddish, for example, picture because it's picking up at the turn-off point or low color temperature, and a while later the shutter is picking up what is the high color temperature. So you will cycle from blue to red and back to blue and red. So you want to stay away from a shutter mode if you are in a fluorescent light and using a CCD camera. This next picture shows that if you use your shutter correctly at 1/60th, you will not face this problem. In the next session, we will explore what vertical smear is and how CMOS come into play in the camera.